Recorded now? Okay, now I am. I just did a video of the opening routine for the activity, and realized once I finished it, going into the main part of the activity, that I was on mute the entire time. So yay, go me. So yeah, this is my second attempt at trying to give a little assistance for those students that are quarantined or at school, because I am quarantined, and I will be for the next, I don't know, whenever they tell me I can come back to work. But you still need to be taught, and you still need assistance. So I'm here for you. I'm going to share my screen, and we are going to try to get this together and get it as easy as possible for you. All right. Making sure that I'm still recording? Yes. Okay. So today's activity coincides with day 22. And days 22 is which of one of these doesn't belong. So pause your screen and or pause the video and just take a look at it to see if you can determine which ones belong and which ones don't belong. Okay, so pause. For those of you that paused, I appreciate it. For those of you that did not pause, this dialogue sounds kind of weird. But in any case, you take a look at the four items, and you notice that three of them are parallelograms. They have, or not parallelograms. They are, well, yeah, actually, yeah, no. One's a trapezoid. And two of them are parallelograms or quadrilaterals. All three of them are quadrilaterals. The blue, orange, I guess that's orange, and white. Whereas white, green, and orange have a base of 6, you could then determine what their areas are, their perimeters are. 8, 12, so 8, 14 for the rectangle, 8, 14, 16 for the trapezoid, 14 for the triangle, and then 7 and 7, 14 for the, what is that, an arrowhead? Oh, it's a parallelogram. So they all have that, or a majority of them have that 14 in common. The only one not would be the orange one. So again, make sure that you have rational thinking and that you're using mathematic terminology in order to give yourself the best chance to get it. All right, now let's go along with today's lesson. Today is the 12th, coincides with day 22. All right, our learning targets: create and describe graphs that show the relationships between the measurements of squares, justify whether the relationship shown on a graph is close enough to a straight line through the origin that it might be a proportional measurement with some measurement error. That's the human error part. Recognize that when we measure quantities in a proportional relationship, measurement error can cause the graph to not be perfectly straight and the quotients to be not to be exactly constant, mainly because we're not using the exact numbers. We're using a rounded off or a rationalized version of those numbers. You know me, accuracy is not necessarily the greatest thing so long as you understand the concept of it and the relationship between it and the other proponents. Key questions: what does a graph of a proportional relationship look like? Easy. It looks like it's a straight line going through the origin. If we measure the quantities in proportional relationship in our graphs and measurements, what will the graph look like? It'll look like y of x with as equal to k and y equals k times x, where the graph goes through the origin. Okay, this activity is kind of, I was kind of looking forward to this activity because it seemed fun, but unfortunately I'm not going to be there, so we'll just do the best that we can. All right, so when going to the activity in Canvas, Let me show you. This is tomorrow's activity, in case you want to sneak a peek into the future. Excuse me a moment. I hear my son in the background going, yeah, 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 like Animal from the Muppets. It's about to make me laugh. So anyhow, don't you remember when we were all on Zoom and all the intricacies of it? You'll notice that I have the entire week set up, but it's locked until those days, and they will unlock at night, and you'll be able to access them the next morning. Please do them during the class, not before the class or after the class, so that the teacher that's covering your class has a nice day, so to speak. All right. So for starters, let's see if Mr. Alex will read for us today. He wasn't reading a second ago, and I don't know why.
Additional assistance. To better assist students on the computer, they may click on the links to an external site, to the Jamboard for this activity, or choose to go about the activity at their own pace. Please do not reuse a student's page. To further keep your work honest, you may choose to make a copy of the Jamboard yourself instead of collaborating with the other groups of students.
All right. So this is a picture of the Jamboard. And I'm going to click on the link, and it's going to take me to the Jamboard. And I think I set it up with the share option, so hopefully it works. I have to add some duplicates so that more students can use it. Hopefully that's enough. Let me see how many we got. Boop, 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 boom, 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 boom. All right, let me add some more. All right, the instructions are on the first page, but these are the same exact instructions that are on the Google Doc. Now, for whatever reason, I can't make it bigger, but if you just zoom in or you hit zoom to 200 and then zoom in, you'll be able to read the same things. It's the same exact question, same exact stuff that's on the main page, as well as on the Google Doc. All right, but like I said, for whatever reason, I can't make it any bigger. All right, so what you're going to do, if you're going to use the Jamboard, is you answer. Hold on, let me make this bigger. And let me make that smaller. Okay. You go to the next one, right? And what you're going to do is you're going to pick 3 squares. Okay. And you're going to get the diagonal and the perimeter of each of the squares. Okay. And you are going to then document those numbers right here. You're going to also put it into the what do you want to call it? The graph at the bottom. You will notice that there is a trend that occurs, and then you will graph that trend. You will need 2 other sets of data from 2 other people or 2 other groups, 2 other partners, 2 other sets of partners. Basically, you want to look for the numbers that aren't yours. So if everybody did A, it doesn't help you at all. I couldn't find anybody that did I. Okay, well then do it yourself, because it's really not that hard. Remember, perimeter is 4 times the side of a square. Make yourself a lot easier. This perimeter diagonal thing, you want to do that last. All right, so the y over the x, and you'll notice a trend. Okay, going back, you're going to notice that trend. What do you notice about the points on the graph? You want to put that answer in here. If you do all that, you've done the entire activity. Now, you can then screenshot this, add it to your day 22 up here at the top, and then I'll be able to zoom in and take a look at it and all that stuff. All right. If you want to. Now, if you don't want to do it that way, that's perfectly fine. You can go about it this way. All right. So what you're going to do is you're going to pick 3 sets of squares. All right. You got 3 sets of squares, and what you're going to do is you're going to go down and you're going to pick those 3: A, B, C, D, E, F, G, H, I. In all honesty, it really doesn't matter which ones you pick and what letters that you call it, so long as that you put them in correctly. All right. So you're going to come up and you're going to go to, say, A, and you're going to get the dimensions of it. So this is 1/2 inch, 1.5, 2.5, 2.5, 3. So 2 7/8 right there, right? You can move it over. You convert that from 2 7/8 to centimeters. You multiply it by 2.54, and you have it in centimeters, right? This is how you could use the Google Doc to make your life easier. All right. In the event that you want to pop out the ruler and get the measurements again, it's okay so long as you use the same sets of measurements. So if you use a ruler, it may not match up the way that you think it actually does paper-wise because of zooms and zooming in and out. But it should be relatively simple to do the conversion of 2.54 times the measurement that you have. So then you're going to put that in here, right? Further down, you're going to notice that you have to graph. If you're going to graph, take a look at the link. You want to go down to perimeter of a square, and it gets you to the automatic graphing simulation. So you want to take this down to perimeter of a square. Hey, Bob, give me a kiss. You have a nice day at school. All right. You go to the graphing point to it. Again, you're going to put your points in here wherever you want. Boink, boink. Hold on a sec. Boink, 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 boink. And then if you didn't like it, you can delete as you go. All right. So delete that one, delete this one, delete this one, delete this one, delete this one. If you ever want to take it back to its original, so I got dink, 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 and I want to take it back to the original. I just hit, nope. Just hit this button, that button, and it goes back to the original. All right. Remember, you can go and screenshot this, add it to on top of this graph, or you can delete this graph, add that screenshot. However you want to do it, makes yourself a lot makes it easier for you. And then again, what do you notice about the points on the graph? Then the last thing I want you to do is I want you to take the perimeter and divide it by the diagonal, and you will notice that there is a trend and that it should work out. All right. Can you turn that light back on? Yeah, thank you. So this should be relatively easy. Okay, hold on a sec. And it should be relatively simple for that aspect. And now we'll go take a moment. That is the activity for the most part for today. If you want, you can take a look at the, sorry, exit out. You can take a look at the original part of the lesson, and it's all right here. See, babe. And you can even take a look at what the goal is and the synthesis of it. Oop, there's the hint. Okay, and go from there. Should be relatively simple to do. At this point, at the end of the lesson, you would go to the, I would go to the reflecting closure bank. Again, go to day 22. There you go. What is the perimeter of the figure? Okay, so side A is 150. And the perimeter is 900. Okay, what is the perimeter of figure B? Well, the ratios are the same. So you would take a look. I did it wrong. I'm sorry. The ratio is the same. So if this is 150, it's going to go up to 900. What's the ratio? What is the K, so to speak? And that the K is the same way. So you would take that K and multiply it by 250, 225, and you would get the perimeter of it. All right. So what is the proportion? What does the graph of a proportional relationship look like? Again, it should look like a linear, either negative or positive, but going through the origin, and that is the extent of the activity today. So shouldn't take you very long, and again, I haven't done one of these in months, as evident of having to redo it with the blooper reel on the first video. Maybe I'll show it to you one day. Everybody take care. Hopefully they'll let me in the building soon. All right. Bye-bye. Bye-bye.